Hello and welcome to the channel. So this is the part 4 series of chapter number 3, solar radiation of the reference book SP SUKHATME. And in today's lecture, we will study about global radiation, beam radiation, and diffuse radiation. And what are these three types of radiation? Now we have already discussed about what is beam radiation, what is diffuse radiation, and the sum of these two radiation is known as global radiation. And in today's topic, we will have a brief introduction about what is the unit and on what basis do we calculate these values. Okay, now first of all, uh, the global radiation is denoted by Ig, and this is known as instantaneous global radiation, and it is denoted by watt per meter square. Its unit is watt per meter square. And beam radiation is Ib, instantaneous beam radiation, and it is denoted by watt per meter square. Similarly, the diffuse radiation is denoted by Id, that is the instantaneous diffused radiation, and the unit is watt per meter square. Okay, now this can also be written as watt, can also be written as a joule per second, joule per second meter square. Similarly, joule per second meter square and joule per second meter square. Okay, now these three value does not rapidly changes with respect to time. For a change of time of 1 second, these value does not changes rapidly. Hence, we calculate these three value on the basis of on hourly basis. Okay, now these value does not change with time rapidly. If you are considering a change in time for per second, okay, now what we have to do is we calculate these three values on hourly basis, because for an hourly basis the change is visible. Okay, what I mean to say is, let us suppose this is I intensity and this is a VR, this is 0 and this is 3600 seconds. So for a change every second, the value of I is very small. Okay, that the value of I is very small for change of second. Okay, but for a change of an hour, that means the value at this point and the value at this point, the change is visible. Okay, 3600 second means 1 hour, and the change is visible. That's why we consider Ig, Ib, and Id on hourly basis. We represent, therefore, we represent Ig, Ib, and Id on hourly basis. Okay, that is the unit becomes a kilojoule per meter square hour. Okay, why kilojoule? Because if we are considering the value in joules, it is very high. Okay, that's why we take the value in kilojoule. So it changes from joule per second meter square to kilojoule meter square hour. So let me conclude this. That is, for every second, the change in I is very small. Okay, as we can see from the graph, this, let us suppose this is 1 second and this is 2 second. The change is very small. Okay, but on the hourly basis, the change is pretty large. Okay, but there is a significant change for every hour. Okay, that's why the unit changes from joule per second meter square to kilojoule meter square per hour. Okay, now let us try to draw the graph for 1 day. This is 6 a.m., 6 p.m. Let us suppose at 6 a.m. the intensity of the radiation, I'm talking about the global radiation, it has this value and it changes, okay, accordingly. So this graph, if I join all the lines, this graph represents, this line represents Ig, okay, and the unit is kilojoule per meter square. Okay, the every point on this graph represents the time on hourly basis. Okay, now the area under this graph, now the area under the graph represents the global flux over a whole day. Okay, the area under the graph represents the global flux over a whole day. What does this mean? That this area, that the area under the graph, this is what, this is the global flux over a whole day. Okay, and it is denoted by, and it is denoted by capital H G. Okay, so this is global flux over a whole day. Similarly, let us suppose I need to draw the graph for I, B and ID. Okay, so this graph represents IB and this graph represents ID. Okay, now area under these two curves for IB, this area is known as HB, and area under the ID is known as HT, global diffuse flux, and this is the global beam flux. Okay, now what is the unit of these three values, Hg, Hd and Hb? Their unit is in kilojoule per meter square day. Okay, now the value that we have calculated are for one particular day. Okay, now these three values are calculated for a particular day, on particular day, but as a researcher we need these values on monthly average basis. Okay, what does it mean is, let us suppose I'm considering the month of January. Now January of 1st, let us suppose this graph represents IG. Okay, now first of all IG is equal to ID plus IB, and HG is equal to HD plus HD. Okay, now let us suppose for January of 1st, the graph is something like this, and for 2nd January the graph is like this. For 3rd January, graph is like this. Similarly, for 31st of January, the graph is like this. Now for every day, the graph of IG will be different, but we want a monthly average graph. Okay, we cannot study each and every graph for every particular day. That's why we want all these graphs to give a particular average value. Okay, for a monthly average, we just draw a single line, and this line represents the value of IG on a basis of monthly average. So we represent it by drawing a bar over it. Okay, and the unit is kilojoule per meter square day. Okay, and we have calculated it on the basis of the monthly average. Okay, now similarly the area under this graph, that this area, what does this area represents? This area represents the monthly average of global uh, uh, global flux over a whole day. Okay, similarly I have to write IB bar and ID bar and HB bar and HD bar. Okay, I hope the concept of monthly average is clear. Okay, so let me conclude today's lecture. Now first of all, IG, IB and ID, they are instantaneous global beam and diffuse radiation, and the unit is watt per meter square. Okay, now for a change in second, the value of these three does not change significantly, so that's why we consider on the on hourly basis. Okay, so this unit changes to watt, sorry, to kilojoule per meter square hour. Okay, why we consider on the basis of on hourly basis? Because for a 1 second, the change in these three values are not significant, but for a non on hourly basis, there is a visible change in these values. Okay, that means that this graph represents every point on this graph represents Ig on hourly basis. Okay, and area under this graph, this is Hg on for a particular day. Okay, now area under the curve means that we are integrating the value of Ig and we are getting Hg. Okay, now this is for a single day. Now, but I want to calculate these value for a particular month. So for a particular month, these value changes to Ig bar, Ib bar, Id bar. Okay, and these are monthly average of hourly global beam and diffused radiation. Similarly, Hg bar, Hb bar, and Hd bar, they are monthly average of daily global beam and diffused radiation. Okay, now what is Ig bar? Ig bar is the average value. Let us suppose this is the first day of a month, this is the second day of the month, this is third day of the month. Similarly, this is the 31st day of the month. We need to have an average value. So the average value of this graph can be shown by this. So this graph represents Ig bar, and area under this graph is Hg bar. Okay, I hope you understand the concept of monthly average and the daily average. Okay, so thank you for the lecture.